I appreciate all of you sticking around and coming to our session at the end of the day. I'm George Roussos, and I will be presenting with Narganopathy, and welcome to Building Metro-Style Apps that Connect to Specialized Devices. Today, before I came to Microsoft, I used to work on writing software at a hardware company, and I was kind of frustrated at how hard it was to do so. Here's a couple examples. When I was first tasked with writing an app to talk to the device I was working on, I was given an internally developed compiler and development tools to use to do so. The first week of using those development tools, I filed over 30 confirmed bugs with those tools. Another example is, it took me over a week, I think it was a week and a half, to learn how to use a specialized library just to display information from my device on the screen. When I came to Microsoft, I wanted to change that. And I suppose it's rather apt that I'm a program manager in the team titled Hardware Developer Experiences. Today we're going to cover what is a specialized device. We'll talk about why you differentiate one with a Metro-style app. We will explain our device access models and APIs that you can use to do so. When we're done, you should leave understanding how to choose the right API and the access model for your device. So, what is a specialized device anyway? There's a broad and diverse selection of devices people use with Windows today. Users love that selection and value the rich ecosystem of devices folks like you create. As you may have seen if you went to the keynote on Tuesday, or perhaps Robin's talk yesterday, Windows 8 includes a set of built-in experiences for common devices people use every day, like webcams and printers. Partners can extend these built-in experiences to promote your brand, highlight unique capabilities, and delight your users. We know from our telemetry that there are literally thousands of other types of devices people connect to Windows. We call these specialized devices because they often have very unique capabilities and functionality. For these specialized devices, we do not provide built-in experiences in Windows 8. However, we enable you to achieve a similar level of branding and differentiation. Whether your device is a credit card reader, an e-book reader, a fitness or personal health device, or is just an idea you've jotted down on the back of a napkin, you can showcase its unique functionality to users with the Metro-style app on Windows 8. You might ask yourself why. I can't tell you how many different times I've heard over the past 10 years of working with partners like you, quotes like, "I'd like to customize more of the device UI." We realize that differentiation and branding are key goals folks like you have. For specialized devices, we face a couple interesting challenges to do so. The first is, we can't necessarily provide a built-in experience for all these devices with unique functionality. A great example is a credit card reader that requires an application to authorize transactions. Nor does Windows provide API abstractions for all of the unique functionality your devices provide. There is not an API to scan a credit card in Windows today. Even if we did, someone, perhaps one of you out there, will come up with such a new cool device 2 years from now that Windows has no knowledge of. We thought about it for a bit, and it became pretty clear the best thing we could do was to enable you to create your own experience on Windows 8 as a Metro-style app. If you do so, these are the benefits your users will see. As you may have heard in some of the earlier sessions by Robin, or perhaps Eugene or Max, when a user connects your device to Windows 8, setup just happens seamlessly. All the software they need is installed, just like that. Users don't have to do anything to get that software. Once they do so, they can experience all the richness of your device. The richness, the unique functionality of your specialized device. How do you benefit? Well, it might sound kind of trivial to state it's an app. But stop and think about all the things you've heard about Metro-style apps at this conference so far. Because it's a Metro-style app, it includes all the benefits that you've been hearing about through all these sessions. For example, you can develop it in the language of your choice, like JavaScript. You can develop it using world-class tools like Visual Studio. What I would have given to have been able to use a development environment like Visual Studio when I worked at a hardware company. Your users can access it as a live tile on the start screen in Windows 8, some of the most valuable real estate in all of Windows. It can do all the neat things that apps can do, like participate in contracts. And you get to control all the pixels it displays. Well, perhaps not all of them. I believe I stand corrected. There's a slight rounding error that I learned about in the keynote due to the touch sensors. But it's not only a Metro-style app. It's a Metro-style device app. And because it's a Metro-style device app, that application can be automatically acquired when your user connects your device on a Windows 8 system. And it's not just any Metro-style device app, but it's a Metro-style device app for your specialized device, which has a couple additional advantages. First, it can access the unique functionality of your device. In limited but important cases, it can even access a custom driver. And I'll show you a demo of that later in this talk. And a rather interesting value prop we've heard from a few of you is you get to control which Metro-style apps can access your device. Next, I'm going to introduce our access models, which define how a Metro-style app can access a device. Our first access model is what we call the open device access model. It enables many different apps from many different authors to access the unique functionality of your device. An example is a smartphone that you may want to have multiple different applications that can access contacts from to, for example, synchronize them with a mail application or perhaps a social network. Another example is a pedometer, something that tracks how far you've run, where you may want to have multiple different applications that can access and read the information from that device, perhaps upload it to a web service so your users can track their performance over time, and even, if they want to, perhaps share that data on a social network. Our second access model is what we call the restricted device access model. And this is focused on the common scenario where you provide an application and a device as one integrated solution to customers. And you may even want to control which applications can access, which Metro-style apps can access your device. In this model, you, the hardware maker, have total control over which Metro-style apps can access your device. The key question to ask yourself to decide which access model is best for your device is to ask yourself the business question: do I need many different Metro-style device apps to access my device or not? If so, if you do need to enable many different apps, you need to use an API that participates in our open device access model. Next, I'm going to introduce Nar, who's going to describe our device access architecture and the APIs which fit into these access models. Welcome, Nar.
Thank you, George. Hello, everyone. My name is Nar Ganapathy, and I worked at Microsoft for about 13 years. And most of my time has been spent working in I/O subsystem, devices, driver models, frameworks, and such things. So today I'm going to talk about the architecture for accessing a custom device or a specialized device from a Metro-style app. And I'm going into the set of API families that you can use to do so. Before we get into the architecture for Metro-style applications, let's take a look at a typical desktop application that would access a custom device. Note that all your current desktop applications that access your custom device will work in Windows 8. Whatever you did in Windows 7, all the APIs are available in Windows 8. So on a desktop app, you typically have a device and a driver. The driver would be a custom driver, or it could be a class driver. If it is a custom driver, the application would use setup.di APIs to find your device interface. It will then use create file, I/O control APIs to send, get a handle, and send the I/O control commands to the device. If it is a class driver, then you would use the appropriate class interfaces. So for example, if it was a portable device, then you would use the WPD APIs. If it were a HID device, you would use the HID APIs. And if it were a USB device and you chose not to write a driver for it, and you really wanted only one app to talk to it, then you could use the WinUSB APIs. One of the reasons I want to discuss this stack is because the access to the device is provided by very low-level APIs to the app in the desktop model. And some of that would not apply to the Metro-style application model. And I want to get into the reasons why. So in the desktop model, the operating system, in this case the I/O manager, does not really care which application is trying to access a device. It does care about which user is trying to access the device. So through security descriptors, the administrator could configure that a particular device be accessed by user A, but not user B. However, for a given user, all applications are treated equally. So all applications for a given user can access the webcam, or the camera, or the printer, and so on. However, this is not true for the Metro-style application model. As you have heard in Alesha's session during the keynotes, the Metro-style apps run in a secure environment called the app container or the application container. And the main reason we want to do this is to put the user in control. When the user downloads an app, they want to precisely control what resources on their system that the application can use. And in order to provide this control, we actually gate it behind brokers. The application specifies the resources it wants to use by specifying a capability in the manifest. So devices are resources, and by default, we only allow access to some devices like printers and accelerometers to be available to all apps. Any other device, the application has to declare a capability to get access. So when the app is installed, the user can inspect the device capabilities that the app has requested and could allow or deny access to the app. And there is this component in Windows called the Device Access Broker. And this component will actually honor the user's policy request and allow or deny access. So in this example, application A is allowed to access the device, and application B is not allowed access to the device. The application specifies the device capability through the device interface class. So for example, there is a device interface class for microphone. There is a device interface class for portable device services. And these are GUIDs. You might all be familiar with it. These are the plug-and-play device interfaces. And so the application specifies this GUID in the application manifest. And the device access broker will check for this when the app tries to open the device. So in the case of well-known device classes like a webcam or a microphone, we actually have friendly names that map to these GUIDs. But if you have a specialized device or a custom device, you just specify the device interface GUID right in the application manifest. So this concept tells you why one cannot provide low-level APIs access to all applications, notably like the open model that George talked about. So for example, let's say we opened up WinUSB as an API to all applications. Since the user wants to be in control, we have to define a capability for that. And so we have to define a capability like access to all USB APIs, access to all USB devices. And that is something the user will not understand. The user understands a webcam or my printer, and when they download an app, they know which device they want it to access, but they don't want to give it access to all apps, all devices on their system. So this is one of the reasons why we have taken the low-level APIs and made them available only in the restricted model. So with that background, let's get into the architecture for accessing a device from a Metro-style application. So the boxes that are in blue are the components provided by the device developer or our partners. And the boxes that are in green are the ones provided by Windows. So based on our telemetry data, we have identified 4 API families that can be used to access a custom device. And I will go into each of those in more detail. In addition, we might need some modifications to your driver package, the device metadata package, and the application manifest. Like I told earlier, the application needs to specify the device capability of the device it wants to access, and that is specified in the application manifest. We need some information in the device metadata. There are 2 kinds of information. One is something called the companion application section, and this tells the system which app to automatically download when you plug in the device. And there is one other piece of information to make the interface restricted, and I will get into that in a later slide. So let's get into the API families. So like I said before, we did a survey of specialized devices using various data we have. And we roughly categorize them into these 4 categories. They are portable devices. These are your devices like cell phones and cameras and media players. And these devices have some storage in them. They are somewhat intelligent, and they are typically externally connected. Then there are some devices that just appear as plain mass storage devices. They appear as drives to the system and can be accessed through file system APIs. Then there are network devices. There are 2 kinds of network devices. Devices that are accessed in the intranet, like it might be in your home, like your DLNA TV, and devices that are accessible through a online service, like your DVR. Let's say you want to write a MetroStyle app to program your DVR. So there are two kinds of specialized devices. And lastly, we have a set of devices which cannot really be categorized, and they have truly custom capabilities, and they require a driver to express their custom functionality to Windows. So we have API families for each of these. So if you have a portable device, then one can use the WPD API or the Windows Portable Device API. If you have a storage device, then you can use the Windows.Storage WinRT API family. If you're using networking APIs, then you can use the Windows.Networking WinRT API family. And for everything else, we have the Device IO Control API. So like I said earlier, the access model depends on the availability of the access model depends on the kind of API you use. So you can use either the open model or the restricted model for portable device APIs. The storage and networking APIs are available in the open model, and the Device IO Control API is only available in the restricted model. So let's now get into the stack for each of these APIs. Before I get into that, I'd like George to show a demonstration of a MetroStyle app accessing custom functionality from a portable device, in this case, the Nokia N8 cell phone.
Thanks, Narb. Let's see. So on the screen directly to my left, you should see an image of a production Nokia N8 cell phone, which is a device that implements contacts as an MTP device service. And on the right, you should see an example app that we've built based upon our portable device services API that uses the WPD APIs. I'm going to run through quickly showing you this application accessing contents or contacts on this device. So let's see how many. So right now you can see that there are 3 contacts on the device. And now I will attempt to invoke the wrath of the demo gods and add an additional contact. Let's see. That we should be able to see when I run the query again from the PC. Okay, so now you should be able to see there's 4 contacts on the phone. Now let's rerun the scenario on the PC using the MetroStyle app. And you can see that it now accesses the 4th contact. So that's an example of a MetroStyle app accessing device-specific functionality using the WPD APIs over the MTP protocol using all in-box class drivers. Next, Nar is going to describe the WPD API and indicate and illustrate how this app was put together.
Thank you, George. So as George demonstrated, we are using the WPD API to access the Nokia N8 cell phone. So this particular device is implementing the standard MTP protocol, and this essentially uses our class driver in Windows. But on the other hand, if your device does not support the MTP protocol, you can still expose a WPD interface to the system by implementing a custom driver. The device metadata contains a section called the Device Companion Application section. You might have heard about this in a previous session. This section contains the package ID of the application that you want the system to automatically download upon plugging in the device. So as part of device setup, we will download the driver and install it. And once the device is installed and configured, we will obtain the device metadata. And from the device metadata, we go and identify the package to be downloaded. So the application itself is a MetroStyle app. It can be using any language of your choice and framework. The WPD APIs are available in C++ in COM. They also can be accessed from JavaScript using COM automation. So if you have a JavaScript application, you can directly access the WPD stack from JavaScript. However, if you're writing an application using C#, then you might need a hybrid app, an application that contains a C++ DLL that bridges between the WPD APIs and the app itself written in a different language. And there are sessions in the Build conference that show you how to write a hybrid application. And one of our samples also shows that. And the way you typically express a custom functionality in a WPD device is through a device service. And each device service is defined by a device service GUID. And the WPD stack automatically maps them into device interfaces. And so the application manifest, the capability is the device service GUID. If the custom specialized device is a storage device, then the stack is even simpler. So we have the storage device. So it could be implementing the USB mass storage class protocol, and so the class driver would load. The device metadata contains the companion application section, which allows the system to download the right app. And the application itself can directly communicate with the device using the Windows Storage APIs. Since the Windows Storage APIs are WinRT APIs, they are available in all 3 languages, and so the application can directly talk to the device. The capability that one needs to specify in the manifest is the removable storage capability. So like I said earlier, there are 2 kinds of networking APIs, networking devices that we want to target. There are network devices that are inside the house, like inside an intranet, and there are network devices that are typically backed by an online service, like programming a DVR. So if it is a device that's in an intranet, then the device should be discoverable through standard discovery protocols. 2 of them we support in Windows, the UPnP and the Web Services for Discovery protocol. In addition, the device has to support the PNPX extensions for those protocols. The PNPX extensions provide the hardware ID and the other information necessary for Windows to configure the device and be able to download the right metadata for the device. Once the metadata is downloaded, we can download the appropriate application for the device. And then the application itself can communicate with the device using the networking APIs. There are a whole slew of networking APIs, depending on the protocol of your choice that you can use. And the application manifest needs to specify either the internet or the private network capability, depending on whether you want to access the device across the internet or through the intranet. So we'll get into the last set of APIs that one can use to access a custom device. So if you have a truly custom device, like this device that George is going to show a demo on. You have a custom driver, and this custom driver is publishing a device interface class and with a set of I/O controls. And the way you can activate and use the device is by sending a set of I/O controls. And so one of the first things we need to do is to modify the driver package for this device to mark the device interface as restricted. So you'll see our sample does that. This is an important point. If the device interface is not marked restricted, then no Metro-style applications can access this device. Desktop applications can access this device, but no Metro-style app can access this device. So once the device is marked restricted, then the device interface is available for restricted applications. The device metadata for this device should contain, in addition to the device companion app section, another section called the privileged application section. And this section contains the application identity, one or two of them, that identify the set of applications that can access this device. Only applications that are listed in this section can access the device, and nothing else. The application itself is a Metro-style app. We have exposed two new APIs in the Metro-style SDK. These are COM-based APIs. And one is called Create Device Access Instance, and the other one is Device I/O Control, or iDevice I/O Control. They are roughly equivalent to the create file and device I/O control functionality. They allow you to take a device interface path and get back an interface which allows you to send device I/O control commands to your device. Since these interfaces are available in C++ only, and if your application is written in JavaScript or C#, you probably need a hybrid app. And this hybrid app has a C++ DLL that exposes WinRT objects to your application. And at the lower end, it actually issues the device I/O control commands. Then I think it's a good thing that we have this C++ layer, because we find that to communicate with many sophisticated devices, you need high performance buffer manipulation and management, and so which can be done in the C++ layer, and then you can express the higher level abstractions to your application. And the application manifest contains the device interface class of the device interface class for the functionality expressed by this custom driver. So we have a sample that shows this whole thing. We have a sample for the OSR USB FX2 device that shows that has the driver, and it's got the device metadata, the application manifest, and the whole thing. So George is going to show a demo of this driver now.
Thanks, Narb. As Nar showed earlier, this device represents potentially any device. It could represent a cash register. It could represent a data acquisition instrument. It could even represent a prototype of that idea you scratched on the back of a napkin. It actually is an OSR USB FX2 learning kit. And what's kind of interesting about this device is we've shipped sample source code for a UMDF driver for this device in the Windows driver kit. So not only in Windows 7, but in the developer kits you're getting from us this week at this conference, or perhaps downloading online, you get the full source code to all the components that we're showing here in this demo. First, I'm going to show you an example of the app interacting with the device. Let's set the value of the 7-segment display here to our favorite number of this conference. And as you can see, the display on the device changed. Next, let's see an example of the application responding to the device. Let's first get the switch state. Let's see, you've got that there. And let's change the switch state, register for switch state change events. And you can see the application responding as I change the values of the dip switches. Now, to many of you, an application accessing a custom driver using device I/O control is probably old news. What's new here is this is a Metro-style app accessing a custom driver using device I/O control. And I'm going to show you a little bit of its anatomy, but the presentation layer of what you saw is actually written in JavaScript with an HTML presentation layer. And it includes a Windows Runtime component that Narm mentioned that actually calls into the custom driver using device I/O control. I'd like to illustrate some of the source code using a set of strategically placed breakpoints and running through some of those scenarios again. So let's rebuild the app, and let's look at the app startup. So first, at app startup, what the app goes to do right here is programmatically discover or enumerate instances of the FX2 device that it can later open. Here you see the device interface class GLID that Nar described earlier, and this happens to correspond to the capability that's declared in the app manifest. Next, the application goes to create an instance of the Windows Runtime component as an object. And that object is contained in the FX2 device variable. What this does is it calls into the Windows Runtime component, and it performs the call into create device access instance, which in turn can be used to call device I/O control to talk to the custom driver. All right, let's look at setting the 7-segment display again. And let's change the value that's displayed here. And here, what we do is we go to display, read the value that's set in the menu, and set that as a property on the object, which in turn will call this routine, put 7-segment display in the Windows Runtime component, that actually, when I scroll down here, you should see calls device I/O control into the UMDF driver with an ioctl to set the 7-segment display value. We can continue. Let's revisit that get switch state example. First, I'm going to reset the switch values. So let's get the switch state currently. Next, let's register for a switch change event. And here you'll see the JavaScript scores where we register an event handler that gets called in JavaScript when the switch states are changed. And now if I actually change the value of one of these switches, the event handler gets invoked. And if I continue, we should see the value updated on the screen. So that's an example of a Metro-style app accessing a custom driver. The presentation layer is written in HTML with JavaScript and CSS, but you can do that in the language of your choice if you so like. If you attended Kevin Miller's talk yesterday, you would see that he demonstrated accessing the same device using the same Windows Runtime component from C#. I think that's actually pretty powerful. And if we go back real quick to look at some of the source code, like here's the HTML source for the menu that was displayed. Like when I went to go set the 7-segment display value, look at how simple and clean that code is just to display information on the screen. What I would have given to have been able to use something like HTML that was standards-based when I was working on software at a hardware company, instead of having to learn how to use a specific library to do something like that, that would have been amazing. So let's recap what we've learned here today. I invite you, well, first I'd like to add one other point, that Our designs for accessing a specialized device focus on two common scenarios: externally connected devices, as well as devices that are pre-installed and are internal to a new PC. I invite you to differentiate your specialized device with a Metro-style app on Windows 8. Windows 8 includes 4 API families for Metro-style apps to access the unique functionality of your specialized device. They are the Windows Portable Device APIs, the Windows Storage APIs, the Windows Networking APIs, and iDevice I/O Control. Many different apps can access the functionality of your device in the Open Device Access model. And in the Restricted Device Access model, you get to control which Metro-style apps can access your device. There are a series of related sessions which have all occurred beforehand, but I put the information up here for you as well as for our friends online who are viewing this content so that they can locate the slides and perhaps the videos if they'd like to look up that information later. We've put together a lot of information for you to use to learn about building such a solution. Everything starts at the Windows Developer Center, which is where you can download the SDK samples and the Windows Driver Kit samples. We've got 3 samples for the families of APIs that Nar described. The Custom Device Access sample, which is the sample for the FX2 device I just showed. Portable Device Services, which is the sample that the Nokia N8 demo was based upon, as well as the Removable Storage sample, which maps to the storage APIs. We've been putting together a series of white papers related to this content, a couple design guides, which will be published by next Monday, I'm told. And I encourage you to look online at the Developer Center and for these white papers on the Windows Hardware Developer Center over time, where we will also be publishing a development guide, which includes a walkthrough of the FX2 sample for accessing a custom driver. For questions, Nar, myself, and members of our team will be participating in the Tailoring Your App for Devices and Hardware forum on the Developer Center. And we thank you for coming. We ask that you complete the session feedback, and at this point, I'd like to open it up for questions. Please come up to the microphone so everybody can hear the question, and we'll do our best to answer.
I have 2 questions. First question, device like webcams, speakers, which category will you put that in?
So the first question is, devices like webcams and printers?
Or speakers.
Speakers.
Any device that already has a class driver other than the portable storage or the...
Okay. Okay. So you want to take that one about the audio?
Sure, yeah. So webcams and speakers and those kinds of devices are not considered specialized devices. So we have APIs in Windows for accessing them. So you can write an app to access those devices. You specify the capability for those. So
but can you also access them as a specialized driver device or not?
Well, if
do you support
yes, you
filter
can.
driver?
Oh, do you have if you have custom functionality expressed, you have can you say how your stack is built?
Sure, you have a class driver and you have a filter driver on top of the class driver that create another interface.
Yes, that interface you can access through this.
As a specialized driver.
Right.
Yes. And even if you only use the class driver and the built-in audio APIs, you can still define in the device metadata an application that's automatically acquired as well to create your own experience. Your
Thanks.
second question. Okay.
That was
Excellent. Thank you.
I've got 2 questions for you as well. I think you might have answered the first one. Right, so if I've got like a standard device with some sort of differentiation associated with it, how do I bubble that up when that differentiation gets masked off by your API? It feels like I can customize at the bottom, right, with my hardware. I can customize the application, but the communication between the two is kind of restricted, right? When I'm using a device that's approximately a standard device, or even mostly a standard device.
How does the can you explain how your scanner device expresses its custom functionality? Is it through device IO control, or like what API do you use?
Probably like device IO.
So if you're using device IO control, then you can use our iDevice IO control API to access your device.
Or it might be a filter driver too.
So if you can use device IO control to talk to your driver, then you can use our iDevice IO control API to talk to it. Yep.
Okay. Now, so second question. It seems
if you can come to our Ask the Experts, we can also probably walk through it in more detail.
More detail.
Yeah.
All right. So, so second question is, do I have to decide, it seemed like I had to decide upfront which other applications could use my device, kind of based on the packaging. Can I update that list after the product already shipped and after it's already installed?
Yes, you may. However, if the applications are accessing your device using iDevice IO control, they will always be part of the restricted device access model, and there will be a limited number of applications that can be declared there. So we go into more detail about that in our white papers.
I got one more for you, and I promise to shut up. Right. So the third question is, once I've published under that restricted model, what happens when I'm in desktop mode?
So on your desktop mode, there are no restrictions. I mean, the current, it's the same as what we have today. Okay. Remember, the Metro style apps are different from desktop apps. Okay. So the interfaces, the restricted model only applies to Metro style applications. So your desktop application can open your devices using whatever APIs that you have today and work on them.
And to reemphasize and restate one of the things I said, when I said you're in control over which apps, it's specifically which Metro style apps can access your device.
Okay, all right, thanks.
I have a question not on API level and iOCTL, but more on the higher level view, how to make customized devices or specific devices. How can I do a restriction on which kind of Metro app is started, or that a device is only able to start Metro, but no user can switch back to the Win32 or classic environment and so on. So how can I say this is a specific device and I want that only my Metro app is the one and only running and nothing more?
So to restate your question, please correct it if I've misinterpreted. I think you're asking if you have a device that you want to control and restrict access to only one Metro style app, and you also apparently want to restrict access to that device to no Win32 or desktop apps. Is that correct?
Right.
So unfortunately, we cannot. Among Metro style apps, we can restrict it to one. We can achieve your goal, but a desktop app always has access to the device. So you cannot say that this device can only be accessed from a Metro style app and not a desktop app.
Okay, but can I protect that the user can't switch from Metro to the desktop?
Well, that depends. No, you can't do that because the user is in control. The user can always go from Metro to desktop and back. Okay. But you can, if you want to have like a, in your driver, you can decide whether this is an exclusive mode or not. So, for example, if the Metro style app has a handle open to the device, then you could fail the request from the desktop app and so on. You can do that.
Okay, thanks.
Next question.
So I currently have a WinUSB driver I'm using to access a chunk of hardware. What's the story there? Do I have to rewrite that using the UMDF or what?
So our current plan is that you need to make it you need to have a driver with an interface and a device IO control. But if this is a widespread problem, then we will take that as good feedback to relook at it.
I'll emphasize over the past couple days that is what we've provided in the developer preview. We've gathered feedback from a few individuals that I'm going to take back and see if we can evaluate. But just to be clear, our current plan of record and what we've delivered is what Nar just stated.
Okay, so let's say you don't back off of that, then you still need to use device I/O control.
Right.
Then I need to upgrade pretty much my entire driver suite to device I/O to use device I/O control, meaning all the code I've got now and WinUSB I have to kind of throw away, and I have to use device I/O control for that.
Possibly, but perhaps you can come to us during our Ask the Experts and we can discuss your solution.
Okay. And then what was my other question?
So remember, when you refactor your application, you might have a set of code that rests on top of WinUSB. Not all of that code has to be part of your driver. It could be part of your app, and some of that could be in your driver.
Oh, yeah, all I need is
Right.
endpoint access, quite frankly. Just endpoint enumeration and endpoint access via streams. And so that's why I chose WinUSB. I didn't need anything more than that. So, thanks.
Great question. Thank you.
Could you explain the thinking behind limiting the device I/O control to restricted access model?
I'll take that.
For example, like if there's a little robot that they expose in device I/O control model, I'm inviting all the people to create apps for that little robot. I would not know what apps is ahead of time.
Sure. So when we did our research into these scenarios, the one scenario that stood loud and clear for enabling access to these functionalities was what I mentioned earlier. It's the vendor providing an integrated solution of an application with a device to enable specific functionality. And by far, that was the most popular and common scenario, and that's what we focused our solution on.
But that doesn't explain why some of the classes you have both model open and restricted, and why device I/O only is
Can I answer that?
restricted.
Yeah.
Right.
So I think I explained this during the presentation, but the main reason is going back to the user confidence, right? So let's take device I/O control, right? The user can understand that this app uses the robot, right? But the user can, if the device I/O control API is open to any app, then that means that any app can just open any device in the system and send it I/O controls, right? And so that means that we'll have an open-ended model, and the user will not be able to provide the right level of guarantee and isolation to the user.
So would the user have control over which apps can access it and change the access list?
Right. So you could, for example, when you ship the robot, you could, in the device metadata, you can say which apps can use the device, and that is certainly permitted, right?
If someone ship an app, would they be able to have a menu to add that to the access list later on?
No, the device metadata has to be updated by the device vendor, right? And there is an update process that goes through the partner portal.
So if someone else create an app for my device, they have to go ask me, and I have to update every single time.
Right.
No, if you go back to the access model slide that I presented earlier, and I said the key question to determine which access model is best for your device is to ask yourself the question, do I need to enable many different applications, Metro-style apps, to access my device? If the answer is yes, then you have to use one of the APIs in our open device access model for Metro-style apps.
Okay.
Next question.
Is there a custom story for the ARM platform? So the drivers being authored, are they going to work on ARM?
So if you use our APIs that use our built-in class drivers, you get support for all architectures. And at this point, we're not providing any additional information on development of custom drivers for ARM. Any other questions?
Did you say something about a Ask the Experts session?
Yes. We'll both be at the Ask the Experts session, which I believe starts at 5:30 and runs till 7.
Right.
So please feel free to come up to us and ask specific questions, and we'll have a bit more time to go through there. I thank everybody for the excellent questions and coming and attending the last session of the day.
Thank you all.
Please fill out the session feedback.